Hey guys, this is Mr. Grice for Algebra Unit 8.1 Notes, Day 2. Today we're talking about graphing quadratic equations in vertex form. Our learning target today is to be able to graph quadratic equations in vertex form. So, the first part says to compare the following equations and their graphs. So, before we do that, we got to get the first one done. So, it says graph by using a table. Y equals 2x squared plus 4x minus 2. What do we do? First thing I want to know, does it open up or does it open down? Well, it opens up. And why does it open up? Well, it opens up because our a is positive. Okay, when our quadratic term is positive, it opens up. Okay? Now, the next thing we need is we need to know the vertex. Remember, the vertex is the exact middle of the graph. And how do we find the vertex? Well, we find the vertex by using the formula x equals the opposite of b over 2a. Okay, so let's go ahead. We have x equals the opposite of 4, because that's the b, and then divided by 2 times a. Okay, so when we do that, we have negative 4 divided by 2 times 2, which is negative 4 over 4, which gives us an answer of negative 1. Okay, so we always start with the middle. That is one of the most important parts of the graph. Okay, so I know that the middle is negative 1. Okay, and the vertex, if I'm drawing it on that little part right there, is the lowest part of the graph. And remember that the axis of symmetry goes right through it. So when we get to the axis of symmetry, we use the same equation, which means we're still going to get that same answer. We're going to get that negative 1. Okay? Now, before we do anything else, we need to know what the other points are that we're going to be using. Okay? And remember, we want to go 2 points above and 2 points below. So if I go right on the number line from negative 1, that would be 0 and then 1. And if we go to the left, it would be negative 2 and negative 3. Now, it doesn't matter what order you use when you're plugging those in. Okay, now that I know all of my points, remember that these are the points that we plug in. These are the input. So when we plug in, we're going to be plugging y equals 2 times x squared plus 4 times x minus 2. And wherever there is parentheses or wherever there's an x, that's where we plug in. So we have 2 times, we can start at the top, negative 3 squared plus 4 times 2 minus 2. And we get, whoa, 24. What did I do wrong? 2 times negative 3 squared plus 4. I know I did something wrong. Oh, do you guys see what I did right there? And see, guys, I was just about to say, the calculator is only as smart as the person pushing the buttons. Well, I pushed the buttons wrong. That's supposed to be negative 3 minus 2. I'm sorry about that. Negative 20? What's going on here? Guys, I really hope you're yelling at me over there, because Mr. Grice is just all sorts of out of it today. 2 mistakes, back to back. There we go. Ah, that's much better, much easier to graph. Okay, so at -3, we get the point 4. Let's see if I can do this next one without messing up. Hopefully you got it right. 2 times -2 squared plus 4 times -2 minus 2. And we get -2. And then when we plug in -1, did you guys do that already? When you plug in -1, you should get -4. And I'm going to stop with my work right there because I can. Because we talked about our graph, the vertex cuts it in half. And the sides are mirror images of each other. So without even showing any work, I already know that this will be 0 will be -2, and at 1, I'll be at the point 4. And if you don't believe me, plug it in. See what you get. Okay, but now that we've got all of our points in our table, let's graph them. So we've got -1, -4. Then we have 0, -2, and -2, -2. And then we have -3, +4, and 1, +4. Our vertex, or our axis of symmetry, goes straight down, and as you can tell, it cuts our graph in half. Now this graph is really skinny, and it is going up like we said it would. But with graphs like this, we have to be very careful that we make it a point, or not, that our graph is not like that. That's bad. A graph like this is bad. A graph like this, worse. Okay, when you draw your graph, try to make it as nice and smooth as possible. And remember, it needs arrows on it because it goes on and on forever. Okay, so really try to make that curved at the bottom. Okay, now our vertex. Let's zoom out a little bit so we can do a little bit more work. Our vertex is our middle. That's the -1, -4. Okay, that's what we stole. The axis of symmetry is a line, which means it has an equal sign on it, and it is x equals -1. So remember that the vertex is a point, and the axis of symmetry is a line. Okay? Now our y-intercept, PT, remember PT stands for point. Okay? And that is where it crosses the y-axis. And in this graph, it crosses the y-axis at -2. And then the x-intercept is where it crosses the x-axis. And in this case, it crosses 2 times. And it doesn't cross at a specific point. Well, it does, but it's hard for us to tell what that specific point is. And since we don't really know exactly where it is, we need to round the numbers. Okay? So starting with our furthest point right here, the one on the left, that's between -2 and 1, or -1. So I'm going to say that it's approximately -1.5, and our y is 0. Okay? And then with our next point, once again, we have to kind of estimate that one. That's between 0 and 1. So I'm going to say that that's at 0.5, 0. And remember, you're approximating. You're not going to get 100% right on that, okay? That's why we have those squiggly lines there. And now this equation at the very top, the y equals 4x, or the 2x squared plus 4x minus 2, that is written in standard form. Okay? Alrighty. Now, let's look at our next one. It says graph by using a table, and it says y equals 2 parentheses x plus 1 squared minus 4. What's different about that? Hopefully the main thing you're saying right now is, yo, Mr. Grice, it's got parentheses in it. The standard form didn't have parentheses. You're right, it doesn't. Okay? And now there's two ways that we can solve this. Okay? We can use a new way, or we can change it into standard form, whichever one you want to do. And the other class is like, well, I don't want to learn something new. Let's do it the old way. Okay, well, let's do it the old way real fast. What does the exponent mean? Remember, it means that it has 2 of the x plus 1s. You cannot distribute into a binomial. Okay, some of you guys did that on your last quiz, and it didn't really work out that well for you. Okay, so we have to multiply those two guys right there. And I'm just saving you guys some work right now. You do not need to be doing this right now. So, but when you distribute, you get y equals x squared, ends up being plus 2x plus 1 minus 4. Okay, because that's from doing all that fun stuff. Now I have to distribute that too. So now we get y equals 2x squared plus 4x plus 2 minus 4. And are we done yet? No, because now we have to combine our like terms. And when you combine our like terms, you get y equals 2x squared plus 4x minus 2. Okay? So remember, this right here was our original problem. And then we went 1, 2, 3, 4 steps to get it into standard form. And now from standard form, now we have to find the vertex, find the axis of symmetry, do all of those points. Yeah, that's a lot of work, isn't it? Guess what? There's a better way to do it, okay? From this equation right here, even though it looks different, I already know what the vertex is, okay? The vertex, the way we find it is we take the opposite of what's in the parentheses, and this number stays the same, okay? So when I'm finding our vertex, the middle number, I take the opposite of 1, which is -1, and that -4 is exactly what I want. That's the vertex. I can automatically see that, okay? And since I know that my vertex is -1, I know exactly where the axis of symmetry is. Okay, the axis of symmetry, oh, look, it's at -1. I know for a fact that my vertex is -1, 4, -4. Okay, and now we would do the same thing where we go 2 points above, 2 points below. Let's see, so -2, -3, 0, and 1. Now, am I using the same points as I did over here? I am, but we've got a different equation, right? So maybe we'll get something different. So now when I'm plugging in, we get y equals 2 parentheses our x plus 1 squared minus 4. Let's see how many times it takes me to get this right. Okay, so I have 2 times parentheses. We have -3 plus 1 squared minus 4. And we get 4. What happens when we plug in negative 2? What do you get? I got negative 2. Is that the same as we did on the other side? I think so. So we know that our graph makes mirror images, so those are the exact same. And guess what, guys? That is the exact same as our other one. Okay? If you take a look, the 2x squared plus 4x minus 2 isn't that what we just got right here? It is. I know, we're tricky, but we're just showing you that your equation can look different. Negative 2 and negative 2, and then we've got 1, 4, and there we go. So we are making the same exact graph, and now just make sure that you have a rounded bottom and that you've got the arrows going up. Okay? So all of this is the same. The only thing that's different is this quadratic equation is in vertex form. Okay? In vertex form, as we scroll down a little bit, vertex form of a quadratic equation is written like this: the y equals a parentheses x minus h squared plus k, where a, h, and k are all real numbers. Now that's just the math, how the mathematicians describe it. Okay? Now, if a is positive, the parabola opens up. Okay? And that's kind of the same thing as we talked about if our ax squared is negative in standard form. And if it's negative, it opens down. So that first letter is really, really important, or number is really important to us. Look at our example. 2 is positive, so our graph opened up. Now the vertex can be identified from the equation h comma k. Okay? Like we said, h, we want the opposite, and k, we just keep it the same. Okay, and then when graphing, the vertex should always be the middle of your table of values. So every time we find our vertex, that was our yellow point, it's always in the middle, okay? Because it's the middle of the graph. All right, let's do the bottom part real quick, where it says identify whether the parabola opens up or down and identify the vertex. All right, so remember, the first thing we need to look at is our front. That's our A term. Is it positive or negative? Well, if it's positive, it opens up. Okay, and now I want the opposite, which is a positive 3. And then we want the same, which is 9. So my vertex is 3, 9, and I know that this graph goes up. Okay, let's do it again. Positive or negative? Well, it's negative. Well, if it's negative, that means it goes down. Okay, and now I want the opposite of 4, which is negative 4, and I want the same. So our vertex is negative 4, negative 5, and this graph opens down. Why don't you see if you can do 3 and 4 on your own? Go ahead and pause the video, and good luck. Okay, so number 3, negative 5, so that means it's going down. And our vertex is 1, negative 8. For 4, there's no number out in front, so there's a positive 1, which means it opens up, and our vertex is negative 6, 7. Now, I'm going to pause or stop the video right now just because we're getting kind of long, and the back page of the notes will be in video too. If you have any questions on this part or any part of the notes, as always, please come find Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra 8.1 Notes, Day 2, Video 1. Thanks for watching.